Now we're going to go ahead and talk about how to actually factor using synthetic division. So first off, usually when you see four terms like this, you can usually use grouping method. But what you'll notice is when you take out the greatest common factors, 6x squared is not the greatest common factor, x squared is. There we go. You end up with 6x plus 11 on this first factor. Greatest common factor on the second pair is 1. What you'll notice, though, is these are not the same, and they're supposed to be. That tells us that grouping method actually fails, and we have to go through another technique. The other technique being using synthetic division. So the way this technique works is you first figure out what x value is going to make this entire equation 0. So there's a lot of guess and check, and technically it could be anything from fractions to whole numbers and whatnot, so negatives and so on. So technically there are an infinite number of possibilities we could plug in at this point. So there's a way to limit down the possibilities, and the way you do that is you divide, or you take the factors of your first number and divide it by the factors of the leading coefficient. So the factors, I think I said that wrong, so the factors of the constant on top over the factors of the leading coefficient on the bottom. Okay, so the P over Q. So in this case, my factors of 1 are just 1. Factors of 6, there are 4 of them. There's 1, 2, 3, and 6. So that means we have the possibility where positive or negative 1 will work, positive or negative 1/2 would work. So I'm just dividing each one. Positive or negative 1/3 would work, or positive or negative 1/6 could work. So we're going to go ahead and plug some numbers in. Last time we learned about some special tricks and whatnot. One of them being if all these numbers are positive, even if you don't remember anything else, if all these numbers are positive, that means we're going to want to plug a negative number in so that we get 0, because you can't add a bunch of positive numbers together and get 0. So I'm going to try negative 1 as my first option. Also, another little trick, I'm showing you what I'm doing right here, but quick trick of determining if negative 1 or positive 1 works. Positive, if you just add all the coefficients together, if you get 0, then that means positive 1 works. For negative 1, if you just switch the sign of the coefficients that have an odd exponent on the x value, so this would be negative 6 plus 11 minus 6 plus 1, and that gives you 0, then you know that negative 1 works. And that's because a negative 1 to an odd exponent will still be negative. So guess what? We got lucky. This gave us 0. So this is where synthetic division comes in. Once we find a number that works, you go ahead and put that number in the box, so negative 1 in this case. I'm going to go ahead and set up my synthetic, so 6, 11, 6, and 1. So I'm just taking these coefficients and placing them. And go ahead and just perform synthetic. So I drop down the 6, then 6 times negative 1, and then I add, that will give us 5. 5 times negative 1 is negative 5. Then we get 1 when you add those. 1 times negative 1 is negative 1. Add those and you get 0. You should always get 0. This was using the remainder theorem. We're trying to get 0 in the end. It means we got a factor. So we can go ahead and start writing out our factor. So one of our factors is the number, is represented with the number in the box. And remember, you always do the opposite because that's our 0. So x plus 1. And then I'll have 6x squared plus 5x plus 1. Now when it comes to synthetic factoring, you're usually not done. This quadratic probably could factor more, so I'll go ahead and just factors of 6 are 2 and 3. The only factors of 1 are 1 and 1. And if you pair those up, 2 times 1 and 3 times 1, and add them together, you do get 5. So that means this is 2x plus 1, 3x plus 1. And now that they're all linear, I know for sure I can't factor down more.